20th century man made a big mistake, thinking that you needed stored energy, you know, like some fuel or some batteries or something to move across the earth. And they took this by anthropomorphizing the automobile, you know, that humans needed food, so cars needed food. What they forgot was that not only is the energy created as you move, people don't even have to eat before they walk, or birds eat before they fly. They're processing the energy as they go. And that's what this horizontal and vertical levitation are, to eliminate gravity, the effects of gravity, so that you eliminate friction. And take friction. You know, the center of the earth is a bunch of congealed electromagnetic fields congealing iron in crystal form that resists change in magnetic direction. So it produces heat, just like your transformers and your batteries and all of your stuff of 20th century technology, the old science, right? So as we rise toward the surface of the earth, we take it step by step into the levitation time that we're in now, right, of the self-propelled car and the flying saucer and so on, and the visits of other planets, you know, of ridding ourselves of the rigid billiard ball universe concepts of gravity. You can see here I mounted 8 generators, 3-phase generators, 6 magnets apiece, right? I built all of these during the MagAmp Gen series 3 years ago, if you want to look in the history of these videos. And this was the lighter one. It produced half an amp approximately with conventional little motors. And this one produced 2/3 with larger magnets. Now this one is considerably heavier, so it couldn't go as fast, I found, and it took a bigger motor that took more energy. Part of the reasons I jettisoned all conventional motors and have built these levitational devices. And the only innovation I've made since then is I realized that I was naive. I was thinking, well, you put digital in the electronic field, so you're going to get digital out. No, you put digital in, you get linear out. The sine curves, right, when you're producing current. So by putting these small magnets on top of the magnets, I did actually like almost a pixelated, primitive pixelated version like an early computer that had the graphic stairways that imitate the curve of the sine curve. And the factories will be able to make curved ones. Remember, you have to, I did it here, the white and red, so that south and north would be differentiated. And you can see them spin. So here's your stabilizer, and it's faced in, and it hits that little metal thing that I put for contact. And here are your levitation magnets. I started out with 4 on the bottom and 4 on the top, and it couldn't lift the weight. You know, it was sinking down. And so I ended up with 7 and 6 below. It's harder to put them below. It's very hard. You can see the multi-level here, you know, and the multi-levels on both ends. But what the upshot was that this one, the lighter one, got balanced by this, but the heavier one, the heavier end, wasn't quite balanced. So what you can feel it when it spins. You can feel that there's still a pound or two. The full load is 38 pounds on these bearings, but it's only a pound or two, but it makes a significant difference in the spin. This one end spins more freely. Even though they're spinning together, you can feel the resistance. So, my point is you better use allowances. You know, I used about 7/8 allowances besides the magnets, and I used them all up and could have used more for the other end, you know. So if you build one, you know, be aware that unless you have larger magnets to send in a V. I tried a big one underneath, it didn't work. It was like tearing the whole thing apart. So that's how you do the horizontal levitation, to remove the friction, so that this turns freely, so that as the air pressure builds up in front of your car, it spins your generator, and you should be getting 10 amps, you know, quite easily. I built it to get 4 to 8 amps, but you can try and get 10. Okay, we're going to demonstrate it. Okay, go. You can see it spinning. I did a cutout on this side so that you can see how it goes. And here's how I did it. This is how the front turn signal that scoops up the air, about a fifth of the conventional fuel cars' wind resistance of their radiators, you know, is shaped something like this, you see? And it's like your mouth will compress air and then expel it. And the shape of this is not like I or E, it's more like U. U. When you say the sound U, you're compressing the air coming out of your mouth. So forming words by human beings is itself similar to this levitational device, and shows how universal these physical realities are. But the shape of the fins have changed, and yet they should be made like a baker's scoop, flour scoop. You know how it's curved and you dig it into the flour and so on. You've seen them, right? They're one piece. And just an extra curve, the curve that these have, like that pick up the air and release a little of it underneath, but concentrate the air action. And because the inner part is outside the diameter of your spinning magnets, of your weight, you know, the moment of inertia will be less. Of course, the more compressed the three-phase generators are, and there's limits to how far out it can be, but it's twice the diameter. Gives a great torsional advantage to the spinning of the air turbines that drive this as you gain air pressure from moving forward. So it should produce 10 amps, as I say, you know, like, and each of the electronic ones. Here I've set up the car, and the next one that I'm building. Here you can see the proportions changed. I said bring out the spinner on the top, and this is 20 inches, the top of a garbage can from the street. And it's less in height. And when I sit here, you can see that this is about the right height when your feet are up 6 or 8 inches off the ground. And you can see the clearance is a few inches between it and the top, which protrudes out the roof, right? So it's fairly low. And when this is low and slightly forward, you get your car design. But not 2 pairs of seats, 3 seats. With this moved up, and this will be more compressed, so it expands the area, but the one driver is there, and this is for groceries and loads and children and so on. So with the 2 chairs here, this is one side. And there's room for your legs and room for the controls for the person. So it's all a compact little car that only needs a few horsepower that's generated as you go by the levitational devices, with the aid of the levitational devices that I've been demonstrating.